Welcome to all. This is class number 2 in the series of analysis of singly reinforced and doubly reinforced rectangular section by working stress method for general public and those who are in the RCC group. That is, the class is going on. For them, this is class 17B. This I already explained for you earlier. So others are class number 2. Now, see, examples for Roman 1 and Roman 2. First, make a note. Somewhere outside you write a note. Roman 1 is for finding stresses developed due to given BM. This all I told in the last class. Still, to understand Roman 1, so many questions are there. That is randomly. See, I will show you. You take a RC beam for the cross section, just make it subjected to bending moment M without bothering what? It is safe or not. We are not bothered. Then, how much stress will come? Remember, here I will tell last time, left hand side M, right hand side is F. M means bending moment for cross section. How much bending moment you are applying? F is, it can be for concrete or it can be for steel. Stresses developed. For, if you use FCBC, it is for concrete. If you use FST, it is for steel. Due to that BM, M for cross section. Here, make a note. Here, see, we are not bothered about permissible stress, under reinforced section, over reinforced section, balance section, how much is the capacity, nothing counts. Simply apply the BM, see how much stress will come. Everything will be crystal clear after one or more 2 classes. I will see this question. There will be 6 questions are here, same numericals. Only BM changes. I will explain later how under reinforced section and over reinforced section from stresses within the limit goes beyond the limit, not now, later. But in general, M, like I told example for you earlier in the class, you go to a hotel, order whatever you want, not randomly order. At the end, you have to pay the bill. Whatever you made order, you have to pay the bill. That person, hotelier, he will not ask you how much money you have got, whether you can pay or not. That is your problem. Suppose you don't have money, he will tell, sorry, that was the items you consumed. So pay for it, that's all. So if you apply bending moment M without bothering about the strength, how much stresses will be developed. Remember, this is Roman 1. I will tell you little later. Roman 2, it is for finding MR. Now remember, MR means strength. How much maximum BM cross section can resist. There also M becomes MR. Right hand side F will come. That F is the permissible stress for that cross section. I will explain later. This all I will tell you. That cross section. Here capacity counts. Like you should, before ordering, you should see what is your capacity. You should be safe. So here under reinforced, over reinforced, permissible, everything will come. So first I will take example of stresses developed for given bending moment. Remember, left hand side is M, right hand side is F. For that BM, how much stress will come? I will remove this one now. Okay, I will remove. This is not required now. This is just one important concept I told. Okay, start. Today, because of festival, Deepavali festival, some crackers are going on. I am recording little evening, late in the evening. Usually I record night time, but night what happens is sound become too much. So I decided little disturbance, no problem. What I hear, you listen. Okay, now. Examples for Roman 1 and 2. Right now we are in Roman 1. I will tell you. Roman 1, A, that is the main question. After Roman 1A is the main question. Later, Roman 1A only, 1, 2, 3, 4, 5 I will give. That is extra questions, homework. Little later, Roman 1B I will tell. Second main question. What I will do is, I should not tell now, one of present one, I made it under reinforced. Other example, I will make over reinforced so that you can learn the concept later. But right now, we are not knowing anything about it. Okay, start. I told question dictated in class. See question. A rectangular section of a RC beam, 300 millimeter. See, cross section of beam in millimeter. Now write the question. A rectangular section of a RC beam of width 300 millimeter and overall depth 600 millimeter has 3 bars of 16 mm diameter in tension zone at effective cover. That is from extreme tension edge to center of steel. Effective cover of 50 mm. Okay, now why I took steel here, little later I will tell. Okay. Why I took X from here also, I will tell later. Now, taking modular ratio M equal to 10.98. I will tell the reason why 10.98. Right now I am telling you believe. Right now I am telling take 10.98, you take it. Taking modular ratio as 10.98, find maximum stress developed in concrete in bending compression or maximum compressive stress developed in concrete. That is called FCBC. And stress developed in steel in tension. That is FST. For when the cross section is subjected to a bending moment of 60 kilonewton meter. 60 kilonewton meter. In the question given, sagging. Okay, I wrote here, see, required to find, etc., etc. I wrote here, etc., etc. I wrote, when the cross section is given, cross section is subjected to bending moment M equal to 60 kN meter, you have to convert to Newton millimeter. Why? Stresses we want in Newton per mm square. So 60, 10 to the power 6, Newton millimeter. Sagging, note, sagging BM, upper side top fiber compression, bottom side tension. So this is the extreme compression at ECE. Don't write that way. From there, you are measuring X. Tension comes down. Okay. Now, first, put the main data. You write here correctly. Breadth of the beam, if you are serious, not B. Breadth or width of the beam B, 300 millimeter. Effective depth D, 600 minus 50. Why? Directly effective cover given. 550 millimeter. Area of steel in tension, right here. Not AST, pi by 4 of 16 square into 3, 603.19. In the question given, modular ratio M equal to 10.98. I told, required to find maximum stress developed in concrete, FCBC, compressive stress, and correspondingly at that time, how much stress will come in tension steel, FST. That is all for when the cross section is subjected to bending moment of 60. If you increase the BM, stress will increase. If you decrease, stress will decrease. That all we will learn later. Right now 60. Okay, start. This I will remove. First, location of neutral axis. That is actual neutral axis. Class. Some will ask, what is actual neutral axis? Later, when you go for MR, you will get a term called neutral axis for a balance section. Therefore, this is the actual, for the given actual neutral axis means neutral axis for the given cross section. Remember, let X be the depth of neutral axis from compression edge. We have equation Bx square by 2 equal to MAST D minus X. See, equation for locating neutral axis for, don't tell shrish like that, singly reinforced rectangular section. Bx square by 2 MAST D minus X B 300 X square by 2 10.98 603.19 into 550 minus X. X will come 135.314. Now 1 minute. The actually M will come not 135.314. It will come 135 point. Just 1 minute. I'll tell the exact value. I'll tell one reason for it now. Not for fun. The reason for telling the value. Somewhere I made a note. Where is it? I don't know. No. The problem is I had searched now. Where I wrote it? 135.314. 319, 9 alla, 31, it is not 9, 31, 135.31, 39, 39, I think 825, 9 or 8, 825 comes. We are rounding up to third decimal. Why I am telling? Because we have got different approaches for finding stresses. Option 1, option 2, option 3. By different options, answer should come same. But since you are rounding up this value, there may be little changes, errors, minute error. If you are getting, see, one stress came, I noted down, 6.835. You may get 6.834. Okay, no problem. So, in case you want exact answer, use the full calculator. But who will do it? Nobody will do it. So, still, I am rounding up to 135. So, the third decimal, you should not bargain. You should not tell later. See, I will write some other number. See, I will write somewhere there 6.835. You should not tell, sir, it is coming 6.836. I will tell, don't come to my class. I already told it. If you want that way, write the full number. So, you got X value. Now, very important, remember, X I am using blue color for some reason. Now I am rubbing the board. So remember now. So first I got, see, I'll get just now. You write all these and write here. Then write a note here. I am writing not here. So therefore, remember X equal to how much? 135.314 millimeter. Because now I am rubbing everything. This all I am rubbing, I will continue. Okay, this portion I will remove, this will be there, still there. Okay, 1 minute. I will write little more and then continue. Because why? Usually I never calculate earlier and take the class, whether offline or online. I come empty hand to the class. But here, time problem. If I keep on calculating everywhere, suppose by chance some calculation mistake, problem. So I prepared somewhere in the corner of the board. I noted down all the answers so that I can save the time. You solve systematically. Okay, now we got X. I'll just, anyway, it will come immediately now. I'll make ready for continuation. We'll continue. See, now X I got. We want maximum compressive stress developed in concrete, FCBC, and stress in steel, tension steel, FST. See, first I will put option 1. I will put this as option 1. There are 3 options are there. Option 1. To get FCBC, I wrote once again what is FCBC. So that, see, I add on extra. Developed in concrete, very important, due to bending moment. How much you eat, pay for that one, that way. Class means I am explaining. There is an expression for M. M means bending moment in terms of FCBC, or you can call it as expression based on compression. See, compression. This all told for you. M equal to Bx FCBC by 2 D minus X by 3. Okay. Substitute M equal to 60 10 to the power 6 Newton millimeter. Substitute here B 300, X is known, FCBC by 2 into D minus X by 3. You get how much maximum FCBC will come. That is how much maximum compressive stress will come in concrete for bending moment of 60 kN meter. Next, to get FST, stress developed in steel, in tension for the same bending moment. Class, there is an expression for M in terms of FST or based on that is based on tension side. M equal to AST FST into D minus X by 3. FST is what I already told. Substitute M equal to 60 10 to the power 6. Substitute here, everything is known, you get FST. So now you can conclude. I write here one conclusion right here. You should write it. There, see, I won't write once again. Conclusion required. I will write the conclusion later when I explain further. Therefore, when the given cross section is subjected to a bending moment of 60 kilonewton meter, concrete maximum compressive stress in concrete that is developed is 5.855 Newton per mm square, and at that time for the same bending moment stress in tensile steel is 197.013. Write that one. Okay, main part is over. Now sounds are increasing. Still I can continue because now nothing to explain further. Okay, now I will go for option 2. Option 2. X we got. Okay, now what you do is, see, to first you get FCBC. I will tell here what to do. First you get option 2. Don't see this one. Do not see this one. Do not see this one. Cancel. FCBC, use expression for M in terms of C. Get FCBC. How much you get? You will get, where is the answer? 5.855 Newton per mm square. Then, I will write here because space problem. I do not want to rub anything. Okay, then I write this side because section is not required now. So what is option 2 I am telling? Get FCBC using M based on compression side. Then once you get that one, then you write here. There is a relation between FCBC, you should write here, I am not writing. Relation between FCBC and FST. That is, if you know how much compressive stress will come in concrete at the extreme fiber, at the same time, for the same bending moment, how much stress will come in tension steel. The equation is MFCBC divided by what? This is to get what? This is to get FST. This is to get FST. MFCBC by FST equal to X divided by D minus X. Now, substituting M 10.98, FCBC we got 5.855 divided by FST. How much you got FST? Sorry, FST you are calculating. FST equal to X 135.314, sounds are increasing, divided by 550 minus 135.314. This will give FST equal to, same answer, guaranteed, 197.013 Newton per mm square. Now, write the conclusion. Okay. This is option 2. This is the correct option. You find FCBC based on bending moment, because once you get FCBC, you can find FST because relation between them. If you know the stress in concrete, you can find stress in steel. Okay, now I will go for option 3. Option 3, see, this is cancelled. In option 3, this is cancelled. I'll remove that one. This is cancelled. See, option 3, I write here. First to get the FST. How? By using expression for M based on tension. M equal to AST FST D minus X by 3. Substitute, get FST. How much will come FST? 197.013. Then, continue. Then, to get FCBC, write once again, relation between stress developed in concrete and steel, MFCBC by FST equal to X divided by D minus X. Substitute FST equal to whatever you got, 197 point. This all will make the concept clear, and calculate FCBC. FCBC will come what you got last time, guaranteed. It cannot change. 5.855. 5.855 Newton per mm square. Therefore, lastly write. See, either use expression for M, option 1. Use expression for M, get FCBC based on compression. Use expression for M only based on tension, get FST. Or, second option, based on M in terms of FCBC compression, get FCBC, use the relation, get FST. Or, option 3, use the relation for M with FST, tension side, get FST first, use the relation, get FCBC. Okay, now therefore, lastly you can tell the given cross section, if subjected to a bending moment of 60 kilonewton meter, concrete maximum compressive stress in concrete at the top extreme fiber because sagging BM is 5.855 Newton per mm square, and at that time stress in tension steel developed is 197.013. Now what you should do is, see, this question is fully over. Now I'll do one thing, very, very important. I'll tell you what to do. See, actually question is over. Now do one thing. For a beautiful understanding of the behavior, after this is class number 2, class number 3 or 4, I will explain the concept of how stresses vary for a cross section, and there sometimes stresses will be within the limit, sometimes beyond the limit, and MR also will come there. So that is for thorough understanding. It will give you correct grip on the subject. So I told one more thing. See, so many people will tell, limit state you are designing. You are not doing working test method. Remember, limit state is imagination. That is factored load. Actually, all the beams, they will almost behave based on elastic theory only, because, see, deflection control, what you do? Serviceability. At service load, you consider elastic behavior only. So, for understanding the basic concept of RCC, elastic theory is very important working test method. Now see, now extra questions. See, first I will write extra questions. Same cross section. Everything same except bending moment M is changing. This will change. So X also will remain same. Only X will, M will change. See, what to do is, I will put extra 1. All extra for what? Remember, all these extra for Roman 1A, not Roman 1B, Roman 1A, I write here. Extra 1 dot. Extra 2 dot. Extra 3 dot. 6 are there. Extra 4 dot. Extra 5 dot. 5 dot is not there, okay. Extra 6 dot. Now, solves extra 1 dot, you take M equal to same sag everywhere M is sagging. M equal, next question, I will give hogging. M equal to, I will give kilonewton meter. Okay. I noted a note there. M equal to 70 kilonewton meter. Extra 2 is for M equal to 70.046. Someone will wonder, how is that 70.046? I will tell you, wait. Right now I am giving you the question. Bending moment of 70.046. I will explain why I give that value. Next 70 of 86 kilonewton meter. After 86, 87 point. Again, some will tell, what is the odd number? There is a reason for it, not time pass. 90 kilonewton meter. I will directly give the answer. Answer, 60 gone now. Answer for all. For all of them, see, I will do one thing now. I will put here. How much is, for each question, how much is FCBC and how much is FST? In Newton per mm square. This also in Newton per mm square. For this question, for this question, for this question, for this question, for this question. Total 1, 2, 3, 4, 5, 6. Okay. For 70, I already solved earlier. 6.831 and 229.849. For 70.046, 6.835 and 230. It should be 230. The reason is there because it is actually this is the 7, whatever. Oh, sorry. See, it jumped. 6.831, 229.849. See, we would have completely wrong then if I have not observed it. Here it is after 60 to 70. 6 point, first, correct, 70 ಆಯಿತು. 70.046 6.835 and 230. 86 8.392 and 282.386. 87.107ಗೆ ಇಲ್ಲಿದೆ 8.5 ಆ್ಯಂಡ್ 286.021 90ಗೆ 8.782 295.520. I will tell you what is this one later. You can see as the BM increases, stresses both in concrete and steel keeps on increasing. Somewhere it will pass, it will touch the resisting capacity. Then it will go beyond the limit. I will show in the diagram here, in the full board, how the behavior, flexural behavior takes place for single line post, rectangle section. That is the basic for RCC. Remember, you design by limit state method. Understand the concept. Okay, now question Roman 1A is over. I will tell you now what I am doing. This is fast I will do, not much time. Roman 1B. This is second question. Full homework. Here also, first main question. Main question. I wrote the main question somewhere. I think it's a paper I wrote it. I don't know. No, I won't bring paper here because someone will tell, I think paper is here only. Yes, paper is not here, it's inside. I won't bring paper because in my entire life, I have never taken a written statement to the class. So I don't want. These people understand. I wrote because to save the time. Okay, here. I will give first main question and then here also I will change the bending moments. You solve both the questions systematically and attend that, go through the other class, supplementary class. I will tell you, this is a supplementary class for that stresses developed, not MR. To understand the behavior of single R or behavior of RCC in flexure, simple language. Okay, I will write the question here, then I will continue. Roman 1B, as usual, question will be dictated by me. See question, dictation. A rectangular section of a RC beam, 230 mm wide and 500 mm deep overall, has 2 bars of 20 mm diameter in tension side at clear cover, not effective cover, clear cover of 40 millimeter. Wide top I will tell you. Then, so B, okay now. Find same as last time, maximum compressive stress developed in concrete due to bending and stress developed in tension steel when the cross section is main question. When the cross section is subjected to a bending moment of 40 kilonewton meter hogging. Remember, hogging. So make a note. Hogging BM, tension at the top. Now this is compression edge. See now this is D, this is X. So your D will be 500 minus clear cover 40 minus half of 20. That all are knowing. And in the question given, take modular ratio equal to 13.33. This is a question. Okay, first, I wrote happily solve. See, I wrote the X value here. Happily solve in the same way as previous question and get for bending moment of 40, stress in concrete 5.857, stress in steel 158.922. Then, here also extra question for 1B. Same cross section, no change. I am increasing the bending moment. See, once extra 1, 40 becomes 47.5. Extra 2, 47.5 becomes 47.805. Extra 3, it becomes 60. No, it is the paper actually. Okay, I will hold in the distance. It becomes 60. After 60, not 60, it becomes 69. 69, correct? I should check it. 69. After 69, it becomes 69.2162. Lastly 70. So 1, 2, 3, 4, 5 extra. Get the answer. Now last time I think I wrote 6 extra. I got into confusion. So do one thing. Over. 5 extra. Last time also 5 extra. Maybe most probably the main question I included. So I will do one thing. The last, this over now, see, question over. Correctly solve. Now, just make a note. See, I will make a note here. If it is by chance 6 are there, cancel. You make it 5 extra now. I write here. I can see the board only somewhere there. So that no confusion. Correct it. See, previous question, that is Roman 1A. Main question is m equal to, it is 60 kilonewton meter. Already over last time. Now, extra questions. Extra for Roman 1A. Okay, I'll put here. Extra 1, extra 2, extra 3, extra 4, extra 5. Okay, I think only 5 are there. Extra 1, m equal to, I'll put here to save the time. Okay, I'll put here. Extra for Roman 1A, I'll give same way. See, I'll give m value here in kilonewton meter. So if any correction is there, refer this one, not that one. I'll write FCBC answer in Newton per mm square, and also I'll write FST answer in Newton per mm square. Why confusion? Okay. 60 already over. After 60, if I come down, next is 70. For 70, answer is 6.831 and 229.84. If any correction is there, refer this one. Second question is 70.046. This will become 70.6, 6.835, and other will become exact 230. Oh. Third extra is 86, bending moment. For 86, 8.392 and 282.386. Fourth extra is 87.107. For that 8.5, important, and 286 point, not, see, I am not good in copying also. Last one, 90. For 90, 8.782 and 295.520. Do one thing. If the last time given same way, solve that one or correct it. What I will do in the other class is, once in the board, I will give the list of the 1A extra question with main question. Then I will give the I write the answer in the board for 1B main question. 1B main question. Then I will explain the behavior. Okay. So solve everything. Remember, if you correctly solve all and understand, first of all you should go through last class where I told all summary. Then understand correctly today's class and class number 3 and also class number 4 for MR. You will gain perfect knowledge for basic behavior of RCC. Okay. See you in class number 3 for general, and for the group class number 17C, I think. I will see, decide. I can tell you in the group, in the WhatsApp. I will send message for you. What is the class number? Okay. Thank you. Disturbance is increasing. So because crackers are just now started. It is 7:05 now.